to another old steam-powered machine shop. My name's Dave, and this is a shop that I put together to depict a 1925 machine shop that you would have found anywhere in this part of the country that would have been concerned with repairing, building, and maintaining machinery for agriculture or industry. We do everything, or try to do everything, the way it would have been done, and use older measuring tools and all the belts on all the line shafts except for one are leather, and we have problems and things that come up, and that's the idea, to see what it would have been like to carry on a business like this on a day-to-day basis. The power is steam. The engine is a engine that was built in 1903 in Wisconsin. The smaller engine that we used to run on the shop on is an O&S engine built in Reading, Pennsylvania. And if you'd like to know more about either the boiler or the engine, you might check some of my earlier videos. I think number 3 is the boiler, and there's one in there, 4.5 I think is the number on it. It concerns the O&S engine and things in general about steam engines. I want to thank you all for your comments and emails during the winter and questions. You're always welcome to comment on my G Plus page. If you go to the channel header for my channel, there's a little orange circle over on the side. Punch that, that takes you to the G Plus page, and it's sort of like a scrapbook of what's going on in the shop here, things that are coming up, things that were done before I even had YouTube videos, and you can always comment on there, and I'm just always glad to hear from you all. So we'll get right to work, we'll get some steam up and get going. Thanks a lot. Before I put this smokestack bonnet back on here, I wanted to just show you how these flues are set up on the boiler. These are 2-inch tubes. This is a fire tube boiler, and they're 2-inch diameter steel, and they come through the top flue head, which is riveted into the shell. And just to give you an idea of the mass of this boiler, this plate here is 7/16 thick, and these holes are bored so that these tubes will just slide through there, and they leave them up about maybe 5/8 of an inch, and roll them with a roller. It's got rollers and a tapered pin that runs down in the rollers, and they spin the whole thing around, and it runs around in here like a ball bearing, and it swedges these out tight against the hole. And then they have a flaring. In the old days they did it by hand. They had a special chisel, and I'll show you what that chisel looks like for actually forming these over and beating them. And it's just a really super neat job they did with this in the old days. And these tubes were considered to be a maintenance item. After so many years, they just cut them on the inside, knocked them out, pulled them out, put new ones in. It was just part of the maintenance of a boiler. These flues are in, I think, excellent shape, because this boiler, actually being a steam crane, it didn't see a whole lot of use, and it was maintained pretty good through its life. This is one of the hand holes in the boiler that's open right now, because I drained it and dried it out over the winter. And you can look in there and you can see this is the water side of the tubes. There's 64 of them in there. That right there is a fusible link. You can see it's got a a hole in it with a special kind of material that melts out at a certain temperature, and if the water level is allowed to get down below that, which is really low on the boiler, that will melt out and blow steam into the tube and supposedly extinguish the fire blowing down into the firebox. Another handhold, you can see the top of the crown sheet where the flues are protrude into the firebox and are rolled the same way in the bottom. These are the fire grates. They're made of cast iron. These are called handholds. There's 10 of them in this boiler. They're for cleaning and inspecting the interior of the boiler, of course. I took them all out in the fall in order to wash the boiler out and dry it out and make sure it was perfectly clean over the winter. And it's quite a heavy casting. Has a special rubber gasket. Turn them sideways and go in. Pull them up not too tight because the heat and pressure from the other side tightens them, and the first time the boiler is fired, you just go around and make sure they're snug and nothing is leaking, hopefully. Tell you a little bit about modern boiler treatment here for antique boilers. My rainwater tanks filled up the other night when it rained, so I've got plenty of rainwater here. But I pumped it into the feed water tanks first because I wanted to treat it. And all I do is bring the pH up to 9. Do your little handy dandy pool pH checker. And I use this stuff here. And this is available from a guy named Jim Connie, who really knows as much as anybody in the world about what goes on chemically inside a boiler. And this boiler treatment is incredibly expensive, but it's really expensive if you have to buy it 55 gallons at a time. So he repackages it and sells it for enthusiasts like us. And you use a couple ounces in each barrel, and it gradually cleans the scale out of the boiler and doesn't allow it to form in there anymore, keeps it from corroding, does all kinds of amazingly good things. So that's, people have asked me what I do to treat the boiler water, and that's it. I've got 150 gallons of very cold water in here. Put a little go juice on the kindling wood. There's the first light up of 2018. I had a thing that bothered me last summer off and on. There would be a kind of a hard pound in the big engine here, and I checked the bearings several times. I thought it was the rod. I took up the rod a little bit and I thought it helped, but I never did really find it. It kind of came and went. So I'm thinking, well, maybe it's the main bearing. So I'm set up on it here with a 2x4 under the flywheel. Let me get this around so you can see it. That's it right there. That flywheel was so heavy that the way I was checking it wasn't showing me what was going on. But that main bearing has definitely got to come up. Now this side appears to be fine. You're getting nothing out of this side, which makes sense because you got a heavy flywheel on the other side, plus the belt tension is on it all the time. So if there was somewhere, it would have to be there. I had that main bearing apart several times, and I thought I had the right clearance on it. So I'm going to try taking out some shims and keep checking it until I get all the bounce out of it. Now these mic out at about 112. 112. So I'll see if I can find some stock. They aren't quite identical, but I think they could be. So I've kept this one marked top. See what I can find for stock that's a little thinner than that. I hacksawed a couple of thinner shims out of some fiber material that I had, and this stuff is about 90, so that's 22 thousandths less, and it'll probably be too tight, but this will be a good base shim, and then I can stack up some thin brass shim stock shims on top of it until I get a little bit of clearance. Okay, as it turns out, it's not that far off, because the difference between being too tight and okay is really just how tight you tighten the nuts. Okay, I'm just starting to feel some drag on it now. So it's about maybe 5 thousandths tight, and I think I'm going to run the engine a little bit and then pull the bearing off, and you can see the high spots. There'll be shiny spots on the Babbitt, and I'll just scrape them down a couple of times and maybe get some more bearing surface going on the top half of the bearing. I've been running the engine here most of the day. Bearing doesn't heat up, loosened up. I tightened the nuts down as tight as I could get them comfortably. And everything seems to be going along fine with this main bearing. I guess it sort of seated itself in. This is one of those deals where you're stretching the capabilities of your equipment to do something it wasn't intended to do. This is a job I'm working on. I started last fall. Luckily, wasn't in a hurry for it. It's an adapter to adapt the chuck to a lathe, and this is the adapter, and I cut it out. This piece here is a press fit into there, and then there'll be some holes drilled and tapped into it. But you got to finish the OD of this, and so you got these big corners here, and I didn't really want to torch them off because it makes a lot of hard spots and it's harder to work with in the lathe. So the old Racine saw that we got last year here. Of course, it wouldn't fit in the vise, so I took the vise jaw off. It'll fit in there pretty nice, and there's a slot right here that the jaw moves back and forth on. It's cast in and it goes all the way through. So, you use a little hold down bolt. This is a shop-made head that holds a boring tool. This is a pretty straightforward job. Cylinder's not too bad, but it's rough and it's pitted, and I want to make it as perfect as I can get it. Also, you notice right here there's a relief. This is bigger in diameter than the cylinder proper over here, and that's because the piston rings come right out to the edge of this and just a whisker beyond, and the reason for that is so that they won't make a ridge as they wear. And as things happen with the connecting rod bearings and the lower main bearings and taking up the Babbitt bearings and everything, the piston stroke could be increased on this end or the other end, and it would hit that ridge and pound and knock. So they always, with steam cylinders, cut a relief here and run the rings right out over it. The rings are really wide anyway. They're like, in this, they're like 1/2 inch wide. So if a 1/16 of an inch of the ring is hanging out over this relief, that will be just fine. And these are the steam ports that come from the steam chest. There's one on the other end too. And that's where the steam comes in and exits. Now, I believe that the steam chest surface is perpendicular to this and parallel to the center line of that, but I'm going to make sure before we go any further. Common writing paper is about 2.5 thousandths thick. It's tight up there. And it's tight down here. So we can assume that this is supposed to be perpendicular to this, and they were trying to make it perpendicular, but I don't know how that was machined at the factory in 1905, but it probably was on a boring mill with a facing attachment. Okay, there's the setup. Now, the tricky part is figuring out how you're going to hold this down. We got a nice hole on this side. Nothing on this side. There's a hole on either end here. Sometimes I come across the top of the chain. Do a little thinking on this and then we'll come back. Okay, so here's what I ended up with. Put these jacks here. I made these 4 jacks that jack horizontally a couple of jobs ago, and they really work pretty neat. So that's holding everything straight horizontally. And then on the front and the back, there's a hole here where the valve rod comes out. It's quite a big threaded hole, and I put one hole down on that. And then back here, I put a pipe nipple in here just to kind of protect the threads. And I did the same thing here. And all these are doing is holding it down, and these are holding it square and straight. And I use these, jack these things in and out in order to get that, get it to line up. And I couldn't do it the way I usually do with a feeler gauge, because this relief back in here really causes some problems in doing it the way I've been doing it, like with the hit and miss gas engines where the bore comes all the way out, the finished size right out to the edge. So there's a couple things wrong. One is when I made this bar, I didn't run the keyway far enough up here to get the head up in here close enough so that I can work it from the back side where I can get to the screws better. Another mistake I made is, let me crank this out here, I could show you better. And I just discovered this. This slot here that holds the tool is not lined up with the center. It's offset 3/8 of an inch in order to put the tool on center. And I made this hold down thing here, and I've got one out both sides, and I picked the wrong one. I had the tool in actually upside down on the last job, and I've always been fighting chatter and surface finish with this thing, and that's the reason why the point of the tool is not on center. So rather than take the thing back out and drill and tap the holes for the other side here, I just turned the tool upside down. I'm going to run the boring mill backwards on this job. So that should work quite a bit better. This is the first skim cut through there to check the lineup. It's about 5/1000. Here's a way the old timers might have set a tool. I want to move the cutting tool out about 5/1000 to take another light cut. So I've got a 5/1000 shim here. I'm going to run this angle plate in here. Tap it till I can just feel some drag on the tool point. Move the point out to the angle plate, tighten the screws back up. I've got this set up for a very light feed, 6 thousandths per revolution, and about 62 RPM. This is the finished cut. I speeded the machine up a little bit and slowed the feed down to 5 thousandths per revolution. This is the formula right here. Feet per minute, speed equals 0.2618 times the diameter in inches times the RPM. We're at 120 RPM right now, so that works out to about 140 feet per minute, which is about right for a finished cut in a cast iron. Quarter of an inch. Take a close look at that and see what we got. There you can see the finished cylinder. There's a couple little pits in it here and there, but I think they're not rust pits. I think they're really casting flaws, and they're not big enough to cause any problems at all. Okay. Check the work and see where we're at. side to side until it'll just, and keep screwing it in until it'll just slide by. Uh, 6-inch 77.5. 6-inch 77.5. Six-inch 77, half thousandths taper. Not bad for a beat up old boring wheel. This is the piston. It's made in 2 parts so that it's easier to get the rings on and off, because the rings are really massive and they won't stretch far enough to get them over the ring land if it was in one piece. So that bolts together, and I guess the plan is I'm going to make up some patterns and send them down to Cattail and have them make some blanks. I checked with getting gray iron cast piece from McMaster-Carr, and it was just absolutely breathtakingly expensive. So we're going to do it that way. The piston is actually about let's see, 25, 15, 10, about 12 thousandths under 6, and we're 78 over 6 on the bore. So that's about it for that. I'll probably just smooth this up just a little bit. I'm not going to hone it. Surface finish is really pretty nice. And that'll do it for this time. Thanks a lot for watching. We'll see you on the next one.